Understand the concept of the partial pressure equilibrium constant, Kp, for a gas phase reaction. The equilibrium constant Kp is formulated using the partial pressures of the gaseous products and reactants, with each species raised to the power of its stoichiometric coefficient from the balanced chemical equation. Write the Kp expression for the given reaction. Using the balanced equilibrium equation, N2O4 is in equilibrium with 2. The expression is Kp equals P2 to the power 2 over Pn2O4. Substitute the known values into the expression. We are given that Kp equals 3.0 and the equilibrium partial pressure of dinitrogen tetroxide, Pn2O4, is 1.33 atmospheres. 3.0 equals P2 to the power 2 over 1.33. Solve for the squared partial pressure of nitrogen dioxide, P2 to the power 2. Multiply both sides of the equation by 1.33. P2 to the power 2 is equal to 3.0 times 1.33. P2 to the power 2 is equal to 3.99. Calculate the final partial pressure of number 2. Take the square root of both sides to. Solve for P2. P2 equals square root of 3.99 approximately square root of 4.0 is equal to 2.0 atmospheres. This matches option B. The correct answer is option B, 2.0 atmospheres.